Okay, today this video is going to teach you the introduction to the double and the half angle formulas for trig. Okay, so by now you should be pretty familiar with when you are given notation that looks like this, and that is our way to tell you what kind of angle we're talking about so that you know where you are on the unit circle. So if I wanted to do this and say 2 theta, that would imply I was doubling it. And if I wanted to say theta divided by 2, that would imply the half angle. Okay, so if you were to want to find the double angle or half angle and you knew where the angle was, it's actually pretty simple of what you would need to do. For A, all I would need to do is double everything. And so if I had an angle that was between pi and 3 pi over 2, this is quadrant 3. So if I double that, I would be between 2 pi, 2 theta, and 3 pi. Now what that means is my angle is now between 2 pi and 3 pi, which is quadrant 1 and quadrant 2. All right, I can do the same thing over here. I can do the half angle, and so if I were to half that, I would do pi over 2 is less than theta over 2, the half angle, which is less than 3 pi over 2 divided by 2 would just be then 3 pi over 4. And so this is actually quadrant 2 between 90 and 3 pi over 4. All right, so if we just ask you where they are, it's not too bad. But let's actually do some stuff. So if I were to pick an angle in quadrant 1 and I were to double it, where would it land? So I'm going to go back to degrees. If you have something between 0 and 90, where would it land? Where would it fall? So let's say I picked 20 degrees, which would be about here. If I double it, what might happen is I would end up with 40 degrees, right? Which would be here. So I'd be in quadrant 1. But let's pretend I took a different angle and let's say I picked, I don't know, 75. That's an angle in quadrant 1. And I doubled that. Well, now I'm at 150, which is actually over here. Okay, so what happens is when you double an angle, it depends on where you are that where you end up. So, for example, all of these angles down here that were closer to 0, when I doubled them, they didn't get me more than 90 to be into a different quadrant. But all of these bigger angles up here that were closer to 90 when I doubled them, that actually pushed me to quadrant 2. So what would happen is if you had an angle in quadrant 1 and you double it, you're either going to end up in quadrant 2 or you're going to stay in quadrant 1. Okay, which if you think about what we just talked about, this is what happens. Okay, you end up with something, a range that's bigger. Okay, so every time you double an angle, you're going to end up with a bigger range, which just makes it an issue in that you don't necessarily know if you are still in the same quadrant or where you ended up because it's a bigger interval. Okay, and that just comes into play with knowing if things are positive or negative. Sine, cosine, tangent, all of that. So just keep in mind when you are doubling things, your interval is widening. All right. Versus when you are doing the half angle, your interval is going smaller. So same thing happens in other quadrants. Like if you were to pick a number in quadrant 3, if I pick, I don't know, 190, which is just shy of, just over the 180 mark, and I double that, well, now I'm at 380, which puts me in quadrant 1 because this would be 360. But then if I took an angle that was closer to the 270 mark, let's say I took 260 and I double that, well, now I'm at 520, which is a quadrant 2. So you are getting a bigger interval. Okay, so what I'm going to do now is let's use what we already know, which is the sum and difference formula, and we're going to use the addition. And if I were to say a sine of an angle plus an angle, so like if I were to have A plus B, what would that be? It just happens to be that I'm using theta and theta. So if you use your sum and difference formulas, then I would say the sine of A, which happens to be theta, times the cosine of B, which happens to be theta, plus the cosine of A, which happens to be theta, times the sine of B, which happens to be theta. Well, hopefully you can see that this is the exact same thing as that. Multiplication, the order doesn't matter. And so really what you have is 2 sine theta cosine. I have 2 of them. 2 sine cosine. Okay. This, I could do the same thing for cosine of an angle plus an angle, A plus B. So cosine is cosine cosine. So cosine of A, which is theta, cosine of B, which is theta. But then I have minus, remember it's the opposite. And then sine of A, which is theta, and sine of B, which is theta. So what I can say is really, I can say I have the cosine squared minus the sine squared. And what we just did is we just proved the double angle formulas. This is the same thing as saying the sine of 2 theta. And this is the same thing as saying the cosine of 2 theta, double the angle. Okay, so here are the formulas, and I'd like you to pause the video and write these down. Okay, this is the sine one. We just proved it. And if you ever forgot it, you could easily derive it like we just did. Okay, here's the one for cosine, and then here's the one for tangent. Okay, so take a second, pause the video, and write those down. Another thing you should know is I could easily change this into something else. So I could have cosine squared minus, I could change sine squared into 1 minus cosine squared by identities. And so really this double negative makes it positive. And so you have 2 cosine squared theta minus 1. So you could also use this. And similarly, let's say I wanted to change this one into 1 minus sine squared minus sine squared. So that means I have 1 minus 2 sine squared. So cosine has more than one just because you can change a cosine squared or sine squared into the other one. But those other 2 come from that main one, which comes from the sum or difference one. Okay, I'm going to do a problem with you, and then I'll have you pause the video. Given that the sine of theta is negative 3/5 and theta falls between pi and 3 pi over 2, find each of the following. So we're telling you to find double angle of sine, cosine, and tangent. Okay, so what I'm going to do is you should always know where you are. Here is where I am. And this is an angle between pi and 3 pi over 2. So this is quadrant 3. All right, so I'm going to draw myself a triangle in quadrant 3, which means I have this. If I'm given information about sine, that means opposite. So this is 3. The hypotenuse is 5. And by the powers of a 3, 4, 5 triangle, this would be a 4. Now, because I'm in quadrant 3, this is going to be a negative 4. So that's really important to know where you are when you're trying to do the thetas. All right, now I'm just going to use the formula and plug things in. So I have to do 2 times the sine of theta times cosine theta. And so I'm going to have 2 times, I'm going to have negative 3/5, and I'm going to have negative 4/5. And so a negative times a negative is going to become positive. 3 times 4 is going to be 12 times 2. This is going to be 24 over 25. And that is my answer. Okay. One thing I want to point out is if I were to double this angle, and remember I can do that. So if I wanted to double my angle, that would imply I was between 2 pi, 2 theta, and 3 pi, which that was quadrant 3, which means now I'm in between quadrant 1 or quadrant 2. Okay. So if I said, okay, well, where did you end up? If I just found the sign, I actually can't answer that question because the sign is positive and the sign is both positive in quadrant 1 and quadrant 2. So if I wanted to know where I ended up, like am I in quadrant 1 or am I in quadrant 2, I would need to do either B or C, and then I'll be able to tell. So I'd like you to pause the video and try to do B and C. Here's your formulas again. And then I'll show you the answers, okay? So take a second, pause it, go. Okay, here are the answers for cosine. And here is the answers for tangent, okay, with a little bit of my work. So you can now for certain say that this angle, when you doubled it, is now in quadrant 1, and that is because the cosine ended up to be positive, the tangent ended up to be positive, and the sine was positive. Now you would really only need one of those to determine that, but if you knew all three, you definitely knew where you were. Okay, and so that's the double angle. Now let's do a little bit of introduction to the half angle. These formulas are a little bit trickier. Go ahead and take a second and pause the video and write these down somewhere. You'll notice that you got a square root and a 1 minus cosine or a 1 plus cosine, and then the tangent has both of them, which should make sense because the tangent is just this one over this one, which is why the 2 is gone, but you have 1 minus cosine and then 1 minus sine. Okay, the biggest thing I want to point out that gets screwed up every year is this plus or minus is not actually there. You decide. You have to be the decider. You have to decide, is it the plus or is it a minus? It is not both. It is not like the quadratic formula where it's there. All right, you have to decide, are you the positive one or the negative one? And you do that by knowing where you are on the unit circle. So let's do an example together. I'm telling you that the tangent is 4/3, and I'm telling you that you're between pi and 3 pi over 2. So again, we're in quadrant 3. So I'm going to draw myself a little triangle. Here is my theta. Sine for this is 3, so this is 5. Okay? So if I wanted to know where the half angle was, well, what I would do is I would just divide everything by 2. So I'm in between pi over 2 is less than theta over 2, which is less than 3 pi over 4. And so if I knew this, then this is definitely in quadrant 2. When you take the half angle of something, you are actually making a smaller interval than what you started with, which should make mathematical sense. Okay, so I'm in quadrant 2. That's important to know because I want to answer this question. I want to know what is the sine of this half angle. So I'm evaluating the sine, and if I'm thinking about quadrant 2, the sine values are positive in quadrant 2. So I'm going to use the plus sign outside of my formula. That is how you decide whether it's going to be positive or negative. Not based on this initial angle, but based on what I'm evaluating. I am trying to find the sine of the half angle, so I need to consider where the half angle is. The half angle is in quadrant 2, and therefore it's a plus sign out in front. Okay, not a negative. The original angle was in quadrant 3, which is the sign's negative, but now when I took the half, it's now in quadrant 2. Okay. All right, but the confusing part is in the formula, you have cosine of theta, and that theta represents this original triangle. And so when I go to do this, I'm going to have plus the square root of 1 minus, and I'm going to use the numbers from the original triangle. So cosine of theta on this triangle is 3/5. So 1 minus, I'm sorry, these should both be negative because we're in quadrant 3. So this is negative 3/5 over 2. And now from there, that's how I start it. From here, it's just a matter of doing some basic algebra. Okay, so this is going to turn in, I'm going to drop the plus sign because I don't really need it anymore. And I'm going to get common denominator. So this is going to be 5 over 5. So then 5 plus this double negative makes it positive. So 5 plus 3 is going to be 8 over 5 divided by 2. Okay, now if you need to, you can do this, make it a fraction over a fraction. So you would multiply by the reciprocal, or I would take half of 8. And so I would have the square root of 4 over 5. If I wanted to go even farther, I could say that this is 2 over root 5, and I did that by taking the square root of the top over the square root of the bottom, and the square root of 4 is 2. And remember what we said, you do not have to rationalize, but if you did, it's your job to know that this is the same answer as before, 2 over root 5 or 2 root 5 over 5, okay? Notice again, it's positive, and that's the half angle. So that's one way to do the half angle, is we flat out tell you, hey, do the half angle. I'm going to show you one more example where it's useful for the half angle, and then we'll be done. So the other thing that you could do is I want to evaluate the cosine of 9 pi over 8. And we did these problems the other day when we said, oh, let's evaluate 11 pi over 12 or something like that. Well, and then what you had to do is you had to be sneaky, and you had to figure out, well, maybe I won't use 11. Maybe I'll use, I don't know, we did 8 or 4 or 7, and you were turning them into like the 3 pi over 12 and 4 pi over 12, and then you could reduce it to a denominator that you knew, right? And then you could do the sum and difference formula. So similarly, I want to use the half angle in order to evaluate this, okay? What's weird about 8 is I could change it into 8 and 1, but then I still have a denominator of 8, and so I don't know what that is. So it's not useful to use sum and difference anymore because I can't break it apart. So instead, I'm going to use the half angle. And what I'm going to do is I'm going to rewrite this as 9 pi over 4 over 2. And I can do that because I didn't really change the problem. And this is saying theta over 2, a half angle. Okay? And this is implying to be your theta that you're going to use. 9 pi over 4 is something that we know. It's something on the unit circle. So what quadrant is 9 pi over 8? The original angle, 9 pi over 8, where is that? So if you think about 8 over 8 would be pi, so that would be right there. So you're slightly over it with 9, so you're in quadrant 3, okay? So what I'm trying to evaluate is the cosine of 9 pi over 8. And we know because we're in quadrant 3, the cosine should be negative. So there is a negative outside the square root, because that is what I want. The cosine of 9 pi over 8, whatever it turns out to be, it better be negative because it's in quadrant 3. All right. I'm going to then use the half angle formula, which is 1, since I'm evaluating cosine, it's 1 plus cosine theta all over 2. All right. Now, what's different about this one is when I go to do cosine theta, I'm using this theta because I'm using the half angle. So this is going to turn out to be negative square root 1 plus the cosine of 9 pi over 4. And that's something that we know, divided by 2. So this is going to be negative 1 plus the cosine of 9 pi over 4. If I was at 8 pi over 4, I would be at 2 pi. So I went all the way around the circle and back again. So this is in quadrant 1. So the cosine in quadrant 1 is positive. And so let me make sure I did the formula right. Yeah, plus. Okay, I got to use the plus. So 1 plus root 2 over 2. That's the cosine of 9 pi over 4, all over 2. Okay, now I got to do some algebra again, and so I'm going to turn this into a 2 over 2. So I have minus the square root of 2 plus root 2, all divided by 2, but all divided by 2 again. And a lot of you might be able to skip this step and just go straight to negative 2 plus root 2 all over 4. And then if you wanted to, you could get fancy and take out the 4 because it's a nice square root number. So you might see it like that. Some people will even write it where the -1/2 is to the side. I ran out of room. So like -1/2, 2 plus √2. Okay, that's the answer, or this is the answer, or this is the answer. Okay, but there's two different reasons why you would use the half angle. And this is one of those ones where I'm trying to evaluate a specific radian. And so I'm going to turn it into a half angle and then use the half angles. Just like you're trying to evaluate a specific radian and you use the sum and difference formulas to do that. Versus this example was we were physically telling you, hey, do the half angle. Okay, and you knew where the original angle was, so you knew where the half angle was. All right, and that is an introduction to double and half angle.